take them down and take them down and take them down, take them down, take them down and take them down and take them down. As you look, the whole room explode down and click you. As you look, the whole room explode down and.
Hi, my name is Aviran. I'm the server group manager for Wix. It's a bit late. Everybody's tired, so my talk is not going to be too technical. What I want to talk to you about is how Wix as a company grew from a small startup to a company with 30 million users. A little bit about us. Wix is a website builder. We have a platform that lets users create websites with a few clicks and drag and drops editor. We have a wide range of products, from HTML5 websites to Flash websites, Facebook, blogs, e-commerce, mobile, and domains. A little bit Wix in numbers. It was founded in 2006. Currently, we have 30 million registered users that build websites. About 1 million users join our platform every month. That creates around 1 million new websites every single month. Every day, since we are a hosting company, we get uploaded with about 1.5 terabytes of files. Currently, we hold 150 terabytes of small media files. We run over 300 servers in about 3 data centers, and we also use cloud services like Google and Amazon. So we didn't start it with 30 million users. We started as a small startup company. And our initial architecture was basically one server and one database. Everything was standard. We used Hibernate, Tomcat, stateful logins. We didn't consider anything regarding to performance or scalability. All we cared about when we started up was getting new features really quick out to the users. We knew once we grow, this would cause a problem. However, we didn't know how hard it's going to be to replace the legacy systems. After 2 years, we found that our initial architectures allowed us to progress very fast. But as soon as we grew and our system became more complex, our development process and new feature releases became slow. But we learned that we did it right. When you have a new startup, you don't really need to care about scale. If you succeed, then you scale up. I meet with a lot of startup companies that they tell me about the architectures, and they said, yeah, we're building caching and sharding and designing the system for like hundreds of servers. And my next question is, well, how many users do you have? Well, we have a couple of hundred users. And I said, well, you don't really need that complex of an architecture. First, start simple. See if you can actually succeed in getting millions of users, and then you will need to rewrite the application anyway, to redesign and refactor. Our mistake was that we didn't plan for such a rewrite when we initially built the architecture. So the server wasn't built modularity, so it was really hard for us to change and refactor. But as you can figure out, we did it anyway. Our next step was to put EH cache because we use Hibernate. Why we do that? No particular reason. It was in the design. We did that mistake. But we didn't stick around with it for too long. It was too hard to manage. We didn't know how to use cache and how to invalidate it. And the operation didn't really get the sense of what does this cache need to do. So eventually we got rid of it, and we didn't really need it. Around a year and a half, almost 2 years after we started, we had a problem. Because we already had some customers that build websites. And we started to notice that every time we did a server update deployment, or we need to change the schema, this would affect our users' websites. And so we find that we basically, after we analyzed this problem, we found that we have two concerns. One, that users' websites shouldn't go down if I need to update the editor. And if I do something on the viewer, the editor doesn't need to be affected. So we have two different SLAs. So what we did is we split our system into two different segments. We got the public segment and the editor segment. The public has a very high SLA. We said, well, users' website should always be up. They should never go down for any maintenance. And the editor server had to expose like editing APIs so our users can edit the website. We use MySQL as our database, and we find out that MySQL really works great as a NoSQL server. We stored a lot of blobs in MySQL. The only thing that we needed to do is make sure those blobs are immutable. So have one table with immutable blobs. Every update, you just write a new record and just update the reference. You have a different table to reference table to point to those records. Currently, we have about 1.5 terabytes of data in MySQL in one database, and it works great. The other problem that we found with MySQL is we used it initially as that we generated the primary key as an auto increment. Now, auto increment has some issues. It locks on the key generation, and you only can work with one instance of MySQL. So you can't really work with two databases as active databases. Our solution was you just switch to GUIDs. GUIDs have a great advantage because they can be generated anywhere, and the chances of conflicts are really, really small. So that allowed us to basically work as a master-master MySQL replication. Wix runs on managed hostings. Basically, when you come to choose a hosting provider, you have like 3 options. You got the unless you build your own data center, you mostly use the co-location, which gives you full control of the hardware that you get. However, you need to get the hardware, ship it to the data center, and provisioning takes a long time. On the other end, you can use cloud services, which give you instance provisioning, but unreliable hardware because you don't really know what you're running on. So we're working on the middle ground, which is the best of the two worlds. We have managed hostings on all our data centers, on 3 of them. So we get the basically overnight provisioning, and we know exactly what hardware we're running on. We also use Google and Amazon cloud services, but that's for redundancy and DRP mostly. Wix, as a hosting company, when people build websites, they upload a lot of media files, and mostly small ones. Think about favicons and buttons and icons and all those small files. When we were small, that wouldn't have been a problem. However, when we grew and a lot of files got uploaded to our servers, we reached like 500 gigabytes of small files. File systems aren't really optimized to handle this kind of small files. And the upload used to upload the files to the application server, which doesn't really build to manage file hosting. So we needed a solution that we can grow with. And we had two major requirements. It has to work with HTTP connections, and it has to scale with the number of files. We also needed control over the caching headers. Another thing that we added later on was dynamic image manipulation. That because we wanted to scale the images on runtime based on the display that you're working. If you look at your site on a mobile device, there's no point for me to download 1080 by 720 pixel image resolution. I will just scale it down to fit the mobile device. So our solution was to build a grid that can handle media files. It's based on Lite. Every file is stored on two machines. And we basically use this as our own file storing cloud. What it does is that it does the dynamic image processing. It's eventually consistent with two copies of the file, but we can always access the file. Once you upload it to one server, it's always accessible. We know how to fall back and find the file to whatever server it got uploaded. Media file caching is very critical, especially when you work with CDNs. That's then about 2 slides away. You need to control the E-tag and the max age. It's very, very important. Before we built that solution, we tried to use the Amazon S3. And that didn't really work. We find that it's not too reliable. Amazon lost us like a volume of 200 gigabytes of files. And they said, well, sorry, we can't restore those files. So we decided to build our own solution. Now we're doing an experiment with Google, but not as our primary storage, but as a secondary fallback storage. We found that using a CDN in the front of Prospero, which is our file storage system, is very, very efficient. For small files, we use Kyoto, Tokyo Tyrant. It's basically key value store that saves blobs. So for favicons and very small files, there's no point of saving them on the file system. It's just a waste of space. And we added memcache. Right now, we're doing a switch to Redis for the in-transit files, so we can. File is uploaded first to Redis and then gets propagated to the servers. So when you go to Wix and get a file, first you go through CDN. If the file's on the CDN, then the CDN just returns the file. If not, then it goes to our main data center, which is in Austin. If the file is not there, we fall back to Chicago, which is our secondary data center. And if we can't find there or Chicago is not available, then we fall back to Google Cloud Storage. When you use a CDN, it's a great connection manager. The CDN basically drops our hit ratio by 99%. But using CDNs, you have to use it carefully, and some things that you need to do. First of all, cache killing is very, very important. Once a file is on a CDN, you almost have no option to get rid of it until it's dead. You can tell the CDN to flash it, but it might take a while. It's not an immediate action. So use a cache killer pattern in the URL as part of a URL or URL parameter. There are many CDN providers. We work with 2 of them. We started with 1. Now we have 2. The thing that you should take into consideration is that every CDN provider treats HTTP headers differently. So you have to tune your HTTP header, especially the caching headers, per your CDN provider. The next challenge that we faced was the development velocity. Our code base became large and entangled. Releasing new features took a very long time. QA between versions took like 2 to 3 weeks, even a month. And after we deployed, we spent few more months to just fix all the bugs that QA didn't find. So we needed to do a complete overhaul in the company. So in mid-2010, we started rebuilding Wix. So we built the Wix framework, which is based on modern libraries. Started rebuilding our entire software stack. In the beginning of 2011, we incorporated the CI, CD, and TDD methodologies. The same year, we started to try out Scala. The first experiment didn't really work, but we're coming to Scala now. We're returning to it and starting a new experiment. It's actually working very good. And we moved to SOA architectures. No more one big blob of a server. It's now basically a lot of different services with their own life cycle. To do all the things that we've done, we know that people are the key. So we needed great people. Basically what we did is, as far as development goes, we replaced almost the entire development team. The ones that could stay stayed, and the one that couldn't keep up just went away. We trained everyone that wanted to be trained, so we sent the entire QA department to learn how to write Java code so they can do automation tests. We started hiring new people. We only hired, because we wanted to build good infrastructures, we only hired senior developers. So when you hire, you don't want to hire a junior if you're building your infrastructure. You don't have time to do the training. During our hiring process, we found that only interview is not enough. Some people know how to talk the talk, but we wanted them to walk the walk. So part of the interview process is also a written test on the computer. They have a coding test. So they have to write code. We need to know that they can translate whatever the design that's in their head to actual code. the interview process, anyone can drop a candidate. It goes through different phases. Usually like 4 people interview a candidate, and everyone can drop a candidate at any time with no particular reason. Well, has to be a reason, right? Another lesson that we learned is that never stop hiring. Once we hit our quota and we said, okay, we stop the hiring process. We found out that about a month or 2 later, a new position is going to get open. So we lost like really good people that we said, well, I really want them, but I don't have a position open. So now we said, well, we're always hiring. Right now we are hiring. So you get the best people. If you see a person that you say, well, I would really like to work with him, even though you don't have a position open, get him. You will have the position open, especially for a fast-growing company. Wix is doubling its size every year. Right now we're like 400 people. Last year we were 200. I only have 5 minutes, so I'm gonna skip those slides quickly. We incorporate a continuous integration and continuous delivery DevOps model. That means no version, always work in the trunk, empower the developers, measure everything, work with A/B test, and monitor KPIs. Those business KPIs are not hard work. In order to do that, we exposed all the information that the developers need in order to do the deployment and monitor productions. So we built a bunch of dashboards. So this is how our developers make a release candidate. Basically, they click on the release candidate button and then deploy to production. They just click another button and they can see everything on the screen that says, well, this is what's going on. This is what the monitoring says. And in case it's not working, I just click another button to roll back. So these are the products that we built, as you can see, from, I guess, 2011. We started the mobile, but from 2011, our development velocity really kicked in. So we built the Wix Mobile, the HTML5, which is a complete rewrite of our application. We started with Flash websites. So we had to rewrite our entire, basically, software stack. We incorporated a third-party integration. Any third party can now, that writes web applications or widgets, can now integrate into our editor and website. We wrote the answers is our support system. We built our own billing system because every geographic location has its own rules and caveats. And this also helps us support the third-party billings. We built an e-commerce system which is based on Magento, and a BI system which is based on Hadoop. Yeah, that's pretty much it. We have lots more of products which I don't want to brag about. Before I let you go, I want to do, well, the shameless plug. I want to take advantage of this stage and announce the Wix Hackathon, which I invite you all to join us for a weekend of hackathon and coding and fun and beer and pizza.
Send them all the details, like in the email. I got your email.
Good. And that's it. I'll be staying here, so you're welcome to come and grab me if there are any questions. I'm happy to answer them.